post it on YouTube, right?
Yeah, so I'm just going to do those two examples today. You know that two I was supposed to do the other day? Then one homework question. Okay. Then Monday I'm going to finish up statics. To finish up statics, it won't be much left. It's about three more examples. And then one homework question. That's the end of statics. We'll start with hydraulics. Okay? Okay. Let me just finish drawing like this.
All these formulas for the area, volume and stuff, it's given to us. No, you need to know, remember. So it's just this one.
But the way they test centroids, they don't. I feel like what we do in class is much more hectic than what they do. They give you a small 5-mark question maybe.
We will appreciate that. Oh, no, my confused, like, I do the same thing.
Because you're expecting hard questions, huh?
So one like this with the circle they won't give us.
No, maybe. It's not difficult, right?
I'm just saying, if you're saying it's a small.
Okay. They may give you one. Right. So, I'm looking at example 4.10, that's on page 94. So they ask you to calculate the coordinates of the centroid of the lamina in figure 4.55 containing a hole of diameter 150 millimeters. Now remember something, remember I said with centroids, we're trying to work out the center point of the shape. Okay? And an example I gave you was, I said that if you have a table and you're only putting one leg on the table, where would you put it? You would put it at the center of the shape. Okay? Center of the shape, why you put it there is because you can balance all the weight that acts on it. So left would equal to right at that point. Now, in terms of this question, they tell you they have a hole in the shape. Now remember that hole, you can't put a center point, like if this was the table top, right? And you can't put the leg at that point because what will happen? It's going to go through the hole, right? Yeah. You can't add that area to it because it changes the weight of it. Of the table when you're doing your calculations, because your center point will also take into account that there's a circle there. So wherever you're doing calculations that involve the circle in this type of question, you're going to have to subtract instead of adding. So when you're doing the area of the total shape, you will subtract the area of the circle. Why? Because there's nothing there. Understand that, right? Okay. So we got 4 shapes here. Right? You can see it's divided into 4 shapes. I have this rectangle A, B, C, D, right? I have the circle, I have this triangle, I have that rectangle. Okay? Now we need to work out our stuff that we need. So firstly, let's start off with maybe working out. Okay, let me call this area 1, area 2, area 3, area 4. So let me work out the areas of the shapes. So the area of a rectangle is equal to what? Right there. Is equal to length times breadth. This will be equal to, what's the length of the rectangle?
450.
450. You'll understand why it's 450? It's at the top here.
I think that's a square.
Yeah, that's a square, right?
It is a square, no, but the way they drew it. But anyway. 450, right?
2 flops today, right? But carry on.
Remember, every square is a rectangle, not every rectangle is a square, right?
Yeah.
Okay, so this works out too?
Oh, wait, no.
184, oh wait, sorry, 202, 500.
This one?
450 and 450. 202, 500.
202, 500 millimeters square. Good. Now, A2. A2 is what?
Triangle, so half base.
A2 is a circle, brother.
What's the area of a circle? Pi d squared over 4 or pi r squared. Right? So, okay, because we got the diameter there, I'm just going to say pi d squared over 4. But remember, you could have also said pi r squared. And what you would have done, you would have halved that out. Okay? So this would be pi 150 squared all over 4, or you would have said pi 75 squared, and it gives you
17671.
17671 millimeters.
See, only one person did the homework.
Yeah.
Teacher's pets.
Okay, A3. What shape is that?
Where's 18? Oh.
Trevor, what shape, Trevor?
Base times height.
It's a triangle, and to work out the area, half
Base times height.
base height. Okay,
So,
half of what's its base?
150
150, right?
so 75.
times
And its height?
300.
Yeah. So what you get?
500.
Yeah.
confirmation.
She's been delayed.
This rectangle, okay, it's a rectangle, right?
Yeah.
It's equal to length times breadth. The length of this is what?
150.
150, right? If you look from the top,
Yeah.
150, right? And its breadth,
150.
Yeah, 150.
you'll understand why, right?
Yeah.
Remember the line from here to here is how long?
450.
450,
Okay.
right? So this side from the top to the bottom is also 450, right? But they tell you that this is 300, so the remainder would be whatever this is. So it will be 450 minus 300. So this line here is actually 150.
So 225.
Right? Okay. So what would be the total area of the shape?
So A1 plus A3 plus A4 minus A2.
You'll all understand that
Yeah.
because of the hole, right? So your total area is equal to A1 plus A3 plus A4 minus A2 because it's a hole, right? So this is 202 500 2 500 2 500 What's that?
Okay. It's 2 to 9, 8 to 8.541.
Are you sure, Trevor?
2 to 9, 8 to 8.541, yes.
You sure kid? Okay, that's your areas, right, of each shape. Now, when we're working on the centroids of the lamina, what's the formulas we use? X bar is equal to the sum of area times its center over area. Total area. Yeah? So, what we need to know, we need to know the center points of each shape. Okay, so I'm going to call this X bar. Okay, so the X bar basically saying the center point of each one of these shapes. Okay,
On the x-axis. On the
but it will have to be at the, it's the X point, right? So x1 would be equal to what?
It will be A1, huh?
Yeah. So so 1 would correspond to like A1, x1 would correspond to that area, y1 would correspond to that, right?
220. No.
no, for 450
What's the
divided by
length of this line?
450.
450. So it will be equal to half of 450,
225.
which is equal to 225 millimeters. X2,
Also,
what would that be?
so half of
75
450 again.
No. Look at the diagram.
150.
What do we?
X2 would correspond to which shape then?
Oh, the circle.
The circle. Right?
So,
What's the center point of the circle?
75.
How? When?
no,
See,
220.
On the
Oh, yeah,
x-axis.
from the
200.
x, okay.
220. So it's
It's 220. They gave it to you where the center
Yeah,
point is,
Okay,
right?
sorry, yeah.
So this here is 220 millimeters. X3. What is X3? What shape is that?
Try.
Triangle.
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 How you work out the center point of that? of how you would work on the center point of that?
It'll be 380, half of 380. No, wait.
No.
That's a triangle.
Yes.
It'll be half of
Half
150 plus 450. Yeah.
Triangle. Go back.
Oh, a third times the
This is
base.
not height.
This is third times the base.
Third times the base.
Yeah.
Right? Remember in the other example we did? Okay? So, that will give you the center point of this. But along the x-axis, it should be
450.
here plus 1 over 3 times that.
Yeah.
Remember the example we did the other day? Right? So this would be 450 plus 1 over 3 times that length, which is 150. Understand that?
That's what
Okay? Remember, on page 89 at the top, figure 4.45.
Oh.
They show you how you get the center point on the x-axis for a triangle. It's 1 over 3 times the base.
Okay.
Same thing for the height, right? 1 over 3 times the height. That will give you the center point here. Now, remember something, 1 over 3 times 150 is 50 millimeters. Remember this axis starts at 0. 50 millimeters is where? Here. Is this the center point of that?
No.
No. You need to take into account this length here plus 1 over 3 times that. And that will give you the center point,
500.
which is?
500.
So now does it look more like that? You see, if you start from 0 here, you go 450, then you go 50. That will take you to the center along your x-axis. Understand that? Everybody's okay with that?
Yeah.
X4. Is that okay with that? Okay, so see, this is your line, right, for the triangle. And we know that the center point to work out this is 1 over 3 times the base.
Yeah.
So the base is 150. And that works out to 1 over 3 times that is 50 millimeters. Okay? Now remember, these here are drawn on an axis. So this is your x-axis, this is your y-axis. So that whole thing is the x-axis. The whole thing is your axis, right? And axis middle point is at 0. So when you're counting the numbers, you'll say 0, 50, 100, 200, 300, 400, 500, 600, so on. Right? So 50 millimeters is actually somewhere here. Anywhere over here, is this the center of the triangle? No, it's here. So you need to add that 50 to whatever distance is in the next shape, or the shape that's next to it. So the length of the rectangle was 450, plus the 50 will give you the location of the center point along your x-axis. You get it? Okay, so for x4, right, which is for the rectangle, how would you do that?
So half length plus 450.
Right? So it will be half of 150, or 450 plus half of 150. Okay? So this would be 450 plus
75.
half of 150, which would be 525 millimeters. Our guys, are we all okay with that?
Yeah.
Okay, let's do it for y. Okay, so y what?
Is half of the height.
So this is a rectangle, it will just be half of the height. Okay, this full height is 450, so
25
it will be half of 450, which is
into 25.
by 2. What would that be?
Oh, so it will be
Okay, which shape is y2 part of?
the circle.
The circle.
200.
The center point of the circle along the y-axis, they give it to you. So you see from this
So
line
it's
here,
200.
it was drawn from the centers, right? So this here would be 200 millimeters. Y3 is your.
So 1/3 your base.
So remember, for the x we say 1/3 of the base. For the height we say 1/3. I mean, for the
Of the
y
base.
it's 1/3 of the
base.
height, right? 1/3 of the height, it'll be 1/3 of this
So it'll be 100.
plus this.
150. So it'll be 250.
So exactly like how we did this way, we have to do it the other way, right? So this would be 150 plus 1 over 3, and what's the height of the
300.
triangle? 300. Okay, so that gives you 250. y4. What would y4?
It'd be 150 divided by 2.
Half of 150. Okay? So, this will be half 150, which is 75 millimeters.
So you're working the center points of the x-axis. Now you're working the center points of the y-axis. Going up now. Remember, that's like a graph, huh?
Yeah.
Each thing is a graph. So,
Yeah.
remember, what those two things are basically the center points of each shape.
Yeah.
So, x1 and y1, 225 and 200. 225, okay, this is not on scale, right? But let's just say 225 was somewhere here. Ignore this 220, I know it looks off, but remember this line was supposed to be much longer than this, right? Just say 225 was somewhere here, and you go all the way up, right? Because from your x, you go, that's how you draw a point in the graph, right? And if you go to y1, which is 225, so you say 225 is somewhere here, that will give you the center point of your rectangle. Now we use all those center points and the areas to get the center point of the entire shape. And what formula you use?
The sum of the area times of this thing times the bar divided by area.
So,
Sigma
xy is equal to the sum of
sigma
the areas multiplied by its moment. Okay, this is the moment of it, right?
all over
The area of the moments all over the total area, right? I can also rewrite this formula as the sum of area times that is equal to the sum of areas, right? Moments, right? All I did was I multiplied this there, that's all. Okay.
Keep that other one on top. We know the other one.
It's the same thing. This is the area of a moment of
Okay,
a specific point. This is the area of the total moments. Okay. This here we worked out this value here at 229,828.541 times x bar is equal to. Now we'll have to do each shape. Now we're looking at x values. So it can be fine like that. This here, remember, is going to be a1 times x1, right? Right?
Okay.
Minus a2 times x2, because remember that's a whole.
Yeah, but if you follow this sequence, what would be easier and keep it in line? So you add all that and then minus the a2 at the end.
I'm going according to how the shape looks. I'm going from left to right. Okay, that one I just wrote it because it said that plus a3 x3 plus a4 x4. Do you all understand why I did this? How I got it? Everyone, right? Now you just substitute, right? So this will be 229,828.541 x bar is equal to a1 is 202,500, x1 is 225 minus a2, which is 17671.459 times x2, which is 220 plus a3, which is 22500, x3 is 500, and then last you have a4, which is 22500, and x4 is 525. So what this whole cell here equals to?
Taking too long, Joe.
I'll just start typing.
You see what happens, because these questions could sometimes end up with long values like that, right? If you put that whole thing into your calculator and divide it by that number, now you may not have enough space. You'll see that sign on the symbol for when you put in your calculator, it starts to sign the symbol. The sign starts to darken itself out because it means you're reaching the end of the numbers you can put into the calculator.
I have 64, 73, 72, 79.02.
Good answer. Put it over this number. What you got? 6?
64, 73, 72, 79.02. Just now double check that.
And take this, put it over this.
So you're
This number.
okay, so the
over
answer divided by that number. divided by
2.
It's not writing this way.
9. Yeah. 281.676.
281.676.
Right number.
Yeah.
Well done. Well done, Trevor. Well done. Took you long, but it's fine.
Okay. Now this is the x component of the centroid for the shape. So its center point of this entire shape along the x-axis would be found at 281. Say 281 somewhere there, right? Whatever, regardless, right? If you're trying to scale, you see it, right? And then similarly, you will do your y substitutions like that. So you would have had the total area, y with the bar, equal to a1 times y1 minus a2 times y2 plus a3 times y3 plus a4 times y4. And the answer you would have got should have worked out to 214,685.
Add 214.530.
You added a textbook again.
This thing's gonna be in the circle.
Huh?
It looks like it's almost gonna be in the circle.
It won't, if
It will be.
No, it'll be just outside the circle.
just outside the circle, cause
220
at
plus
75 is
75.
295.
Yeah, so it's inside the circle.
Oh no, but then look at the height.
Yeah,
Height is inside, not the-
214 is
not
inside
the-
circle.
Not the height, that.
It's all inside the circle.
Yeah, that's right. They must put stats in all around. Yeah.
You got this table there with the hole, and you put
That's what I was trying to avoid, but anyway, I don't know.
you use a bad example, huh? The table.
Okay, but guys, you understand the concept of how you would answer this, right?
Yeah.
Okay, the one with the y, you'll need to attempt it. And I'm not going to do the whole thing because you can see how much it is to actually write on.
Yeah.
But now I'm going to show you all on the next example how you will do it in the exam. Because nobody wants to write so much of stuff. Right? Nobody wants to write each single thing, right? So we do a table. So you'll see it like on page 96 at the top.
Okay. I like it like this way.
This is long.
Oh, science, you know, we have no time for science.
No, but you don't write all the steps. This way it marks you down.
So it's burning for 3 weeks. Get over it. Come on, build a bridge. Calculate the supports. Build a bridge. Get over it.
Jump off it.
How did you get it? It's pretty cute.
I think you just got 2 more now.
No, just one more and then the homework.
What did Evan say? What did Evan say? I think I missed it. At the time.
No, I'm going to
There's
go.
Evie.
I will do it.
It's gonna start doing it.
Ready?
Mm.
Can I take it?
Yeah.
So Centroids is not bad. It's okay.
Hey, there's so much of writing.
That's why I'm showing you this method. Okay. Give you the page.
Let me change the number. What's the number? 11. You're so sharp. You're doing the easy one. You're not so difficult to homework.
No, they don't do homework as easy. So how you would answer this, right? So they want you to calculate the centroid of the area, right? You're going to make a table. Part, area, see, okay, that's your table. Right? Part, area, coordinates of centroid. Okay, what you're going to do, you're going to divide this into four. Not four. Okay. This one you can divide it into three shapes. Area 1, area 2, area 3. Can you see the three shapes, right? It's three rectangles. Okay? So, for your first part in A1, its area would be equal to what? It's a rectangle, length times breadth, right? So it's going to be 25 times 250, right? So it will be 25 times 250, which is
625.
6250, right? Coordinates of the centroid. Remember when we write coordinates, this is how you would write it, and this would be your x-intercept, this would be your, yes? Okay. So remember your axis would start from 0 here, and then you move off, right? Should I must have drawn the axis?
No.
It's fine, right? So what would be the coordinate on the x-axis for the center point here?
12.5.
12 and a half, right? It will be half of whatever that is. Okay? So this here is 12.5. And its y component would be?
125.
125. You understand that?
No.
Yeah.
Which part?
How are we talking about?
So the length of the ear is 25.
Half the length.
Half of the
center.
Oh.
Okay?
It's just the rectangle.
Yeah, it's a rectangle, right? Then for A2, what shape is that?
Rectangle.
Rectangle as well, right? What's its length
17,
and its breadth?
20.
10.
20. Okay?
Oh,
Then
yeah.
is area formula, length times
Oh,
breadth,
the
right?
area.
So what this will come out to,
1,004.
right?
Okay.
How you get its center points? What would be the center point of that
10.
along your x?
So it will be
35 and 10.
35
No,
and X.
no, 35 plus 25.
Right?
yes, yeah.
You'll understand that.
Oh, yeah.
Remember, this is the length of it, right? So you'd find its center point at half of 70, which is 35. Yeah?
Yeah.
But remember, we start from 0.
Oh.
So it will be 0, the 25, plus the 35.
Yes.
That will give you the location of its center point. Okay? So that will come to 35 and 25. Okay? You understand? Who's confused? You all okay? And its center point along the x-axis, y-axis?
Now that's where, now do you assume that it's in the center there? Because the H on the top, I, H and G, C is the same length.
120, the 20 plus 125.
No.
So they didn't give you that
you
measurement.
just,
So
yeah,
you assume
you just
that it's
say
in the
that it's
center.
at the center, right?
Yeah.
You'll assume that it's at the center.
Yeah.
So
it'll be
its halfway point would be at 125. If you start
So
from
what-
0, its halfway point would be 125.
125. So
Okay?
it'll be 125.
This would be 125.
How you got 125?
So,
Oh.
see the full length from 0 to here?
So
This is found at halfway.
So we're not looking
So
at
they
this
didn't give
there.
you the measurements.
Oh,
So you assume
Remember-
that it's the center.
Remember, this is on the
H.
axis, right?
Okay.
So the axis starts from 0. This measurements is just length. The entire length from 0 to here is 250.
Okay.
Right? And the entire length from 0 to here is 25 plus 70 plus 30. It's 125. So when you're giving the coordinate point, if I say 60, I'm going to go 0
Oh, okay.
until 60 and then I come.
So we're not just looking at that shape.
You're looking at that shape
the whole
only for
X,
area.
but
When
with
you're
that
calculating
X.
coordinates, because it's on the axis, you need to everything, okay? A3. There. A3 is what? A rectangle. Formula for a rectangle is length times breadth. It will be 30 times 250, which is
7,500.
1,500.
Yeah, that's right.
Okay. The coordinates of its centroid along the x-axis, what will it be?
That'll be half of that is 15.
110.
85 plus. This is 110 is right.
You understand why it's 110? Right? It's going to be 25 plus 70 plus half of 30. You'll get that, right? So it's going to be 110. Along the y-axis, its halfway point is also going to be 125. You understand that, right? Okay. So in this table now, what you'll see in the bottom here, you'll see total. So if you add these three values up, what you get?
$15,150. 15,150.
15,150.
Zero.
Right. So that's the total area, right?
Yeah.
Because it's areas of these three shapes added. And we know its center points. So now the only thing we need to show now is that formula. Looking at these values already, what will be the y bar for this whole shape? For the center point? 125, right? Because all the halfway points are found at 125. So instantly you can just say that y bar is equal to 125 millimeters. X bar will be equal to the sum of the moments of area all over the total area, right? This would be equal to A1 times X1 plus A2 times X2 plus A3 times X3 all over A1 plus A2 plus A3. So A1 we said is 6250, X1 is 12.5 plus A2, so I said wrong, X1 is 12.5. A2 is 1400, X2 is 60. A3 is 7500, X3 is 110. All over, we worked out the total,
15.
which is 15,150. And what's your value for X?
65.150.
65.157 millimeters. So the coordinates of the centroid of this entire H shape is 65.157 and 125.
Yeah, much simpler.
Yeah? So remember this cut out all the whole board of calculations. Wow. Yeah?
So we need to.
Okay, but now.
No, when we're writing the exam, this is exactly how we do it. No matter what
Exactly. You'll even see if you're going through past year papers in terms of the memo. They'll have the table first with all the stuff, and then they just use that formula to work it. Because the main thing is that formula, and to get to that formula, you need to know these stuff.
So even the first one, you showed us a method.
I showed you that to show you all exactly what's
How
being
we
done.
did it, yeah.
And now we are at the third example. You all should know how we got this.
Yeah, you see, he has to show us how you get it. If not, if he just tells you,
Yeah.
Then you're
You're
going to
going
wonder
to
where
apply
I
it.
got what from, and then it's going to be confusing.
And you hit the same number of marks for 4 papers.
The other one is just long.
It's much easier this.
Yeah.
But this one here, we're lucky we're given y bar.
no, even if to work out why, it's much easier.
Even if you need to work it
It's
out,
the
it's
same
exactly
thing.
how you worked it out, you do the same thing. But with y1, y2,
Yeah.
what's the table?
It would have been more difficult maybe there was a circle on.
You can do that 4.3 and we're done now.
Did you understand though?
No.
You want us to do it? Can we all do it now and then quickly?
Okay, guys?
Tell kids, yeah.
Give us no homework.
No, we can do it
No,
now. Do it
can you
now.
attempt activity 4.3 question 1
Now.
now?
Yeah.
And then I'll give you 10 minutes and we'll answer it, right?
Yeah, I think it's a good idea.
That will be the end of statics. Which one? 4 point? Activity 4 point. Okay, let's answer this. So, when you split it, you would have split it at that point, right? So you ended up with 2 areas. You would have ended up with area 1, area 2. So for area 1, it's a rectangle, right? So to work it out, it will be length times length. So what's its length? 60 times 20, which is 1,200, right? Millimeters squared. Coordinates of the centroid. So its center point along the x-axis would just be half of the length, right? Which would be 30. Center point along the y-axis would be what? 40 plus half of 20.
Yes.
Okay, because remember y-axis starts from 0, that 40, and then half of 20, which gives you 50. Now we're looking at the next rectangle. Part 2, or A2. Center point along the x-axis would be what?
It will be half of 15 plus 22.5.
Okay, so this remaining portion here was also
22.
So 60 minus
22.5, right?
22.5 minus 15 will give you 22.5.
Right? Exactly, right? So that says 22.5. It is 60 minus 22.5 minus 15 also gives you 22.5. The x coordinate here will be half of 15 plus 22.5. You understand that, right? Half of 15 is 7.5. Okay, and its x coordinate will become?
That's it.
Should I work to the area?
Yeah, nice.
Why don't you?
And its y coordinates will be half of 40.
20.
Okay, like that. So this here would be 40 times 15, which is?
600.
So guys, you understand?
50%, don't get it.
50.
Yeah.
Okay, so almost fell off my hand. Then remember, you have that's your y-axis, that's your x-axis. It starts from 0, right? Now, if I want to see where the center point, remember if you're plotting coordinates, right? You'll always start from 0 and then you'll move to whatever number, okay? The center point of the shape here along your y-axis, it's going to be half of 20, right?
Yes.
Correct? That will be if it's just that shape. But remember that shape is 40 millimeters above your axis, your 0. It's a 40 millimeters above your 0. So the center point of the shape, if you're writing it as coordinates, is going to be 0 plus the 40. So you're starting from 0, so it'll be plus the 40 plus half of that. So half of 20 is 10 plus 40 is 50. And if you're plotting it out, right, 30, say for example 30 or somewhere here, and you go all the way up and you come somewhere here, right? And if you go to 50, after 40 you come after here, that will be the center point of that shape. You can see it, right? And then similarly for the other one, 30 is like here, 20 is like here. That will be the center point of that shape. Okay. Then you will work out your total. Your total will be 1,800. Now you use your formula. So you'll say x bar is equal to the moment, your area all over.
Total of 30 minus 20.
Oh, okay, yeah. Then that's fine.
But you wrote out.
I know that's man. There. You can see now, because the center point of these both shapes are 30, your center point of the overall shape should be 30, right? So this would also be 30 millimeters. So you only need to solve for y bar. And this would be equal to the sum of your areas times y all over the sum of your total area. This would be A1, Y1 plus A2, Y2 all over A1, E2. And when you substitute, this is going to be 1, 2 times 50 plus.
If you
60 times
skip that
20.
step, this one you are writing this y1, y2, and
This,
the top one.
this,
Yeah.
no,
And the
that's
bottom one.
This?
Just got this answer.
No, you can't skip this.
So
You can show this. You can show this.
Yeah.
You can go here, right?
Okay.
But that you can skip, but you can't skip you substituting values into a formula.
So if you
That's
get it wrong,
really
then you're
hard.
not going to get any marks. So if you get the answer wrong, you're not going to get it.
Yeah,
Work
you're
out
not going to
10
be
plus
able to
10
do
divided
the
by
parts
10.
anyway.
Yeah.
So what's the answer?
40.
So the coordinates of your centroid is 30.
So if you put it into just write it in here at this on this table.
And that's
No.
what's
For what?
No. The formula. You need to use the formula.
No, but
if you use
the final answer you put it here.
No, you can't do that.
But then you wrote the final answer down, right?
No, he's saying to complete the table.
Oh my God.
That's fine.
Okay, yeah. You can put it, you can put it. I'm not
I
gonna
also
give
put
you,
it in there.
I'm not gonna
That's
give you
fine,
a
that's
mark
fine.
for it, but you can put it there. Okay. We're almost done with centroids. Monday we're gonna look at page 99. That is also not difficult, guys. It's exactly like how you did those questions, right? But we did it for 2-dimensional shapes. The next one you're gonna do for 3-dimensional shapes. And how you would do it for 3-dimensional shapes, you see everywhere where we got areas, you would use volume.
That's it.
That's the only difference. And the formula there would be the sum of volume times y all over sum
Sum
of
of
volumes.
So you need to know, in the section here, you need to know the areas for
You
each
see
shape.
that
Number 4.
Yeah.
Number 7.
on page
Number.
on page 92, they tell you important formula.
Yeah. You need to know that.
That's the important one.
So that's for area and volume, right?
Yeah.
But then you also need to know the y bar and the x bar for each shape.
Yeah, but remember for a circle, it's your radius, right?
But then if you get a cone now, you need to know.
Cone, you on page
100.
90.
90.
You got a cone.
So it would be.
It's
height
1 over 4
for-
times. For triangle, it's 1 over 3 times.
Or a cylinder, you need to know that as well.
Yeah, cylinder along the x should be a radius, and then we half of the height.
Yeah.
But sometimes you see like how example 4.13, 4.14 and stuff.
Yeah.
When they put like a sphere, half a sphere, and a
Yeah.
cone, and a cylinder and a cone, that sort of thing. So,
So they give us.
yeah,
It has to be answered the table because if you don't have that total of 180,
if you don't have,
if you don't calculate it,
yeah. If you did it like you worked on each thing, that's fine too. But I just said this one here helps you save some time because it's long to write each thing, and you're gonna use a lot of paper and all that.
Okay, stamp it. Where if it's too numerals, then stamp it.
What we can stamp the first test paper. So that's okay. We're gonna end there for today.
Okay.
Does anybody have any questions or anything? Good.
Thank you.
Thank you.